What's up, guys, and welcome back. We're going to look at what's called polar coordinates today. So a polar coordinate is when each point on a plane of a two-dimensional coordinate system is decided by a distance from a reference point and an angle taken from a reference direction. So we're going to be graphing stuff that's on this type of circular grid right here, so not like X and Y coordinates. R is going to represent our radius, and that's always how far from the origin we are, and theta represents our degree measurements from 0 degrees, so the polar axis. We don't want to think about this in terms of X and Y, how we think left, right, up, and down. We think about this in terms of starting with our angle measurement and locating where that would be around the circle, and then extending from the center towards that angle measurement is how we're going to approach this. So a couple of ways that polar coordinates are used in the real world are, from a physicist's point of view, polar coordinates are used in calculating equations of motion for the law of mechanical, or for a lot of mechanical systems, and they're also useful when objects are moving in circles. So we're going to look at how to be given some information and then put that on this circular or polar plane. So point A, plotting point A. We're told that we want to plot point A 4 units from the origin, 60 degrees from the polar axis. So what we're going to start off with is always start off with locating the angle first. So I'm going to find out where 60 degrees is, and then I'm going to go from the origin. Each one of those circles represents one radius. So starting from the origin, the first circle, this would be a radius of 1 right here, 2, 3, 4, so on and so forth. So I'm going to go ahead and go up 4, and then I'm going to write this out. So when we write polar coordinates, we write our radius first and then our angle second, like this. But when we graph them, I do them backwards. I locate where it needs to be, and then I graph my point based off of my radius. The second one, remember, negative angles mean we go clockwise. So I'm going to go negative 120 degrees, which is going to be right here. And I want to go 2 units from the origin. So going from the origin towards 240, I'm going to put my point B right here. And then when I write this out, it's radius first, comma, the angle. So I would have 2, comma, negative 120. All right, let's see if we can plot each one of these points. Now, we do have negative radiuses here, and it's not that bad. We're still going to start off by identifying the angle first. Let me show you what the negative does. So 270 degrees would be right here where I have highlighted. And if that was a positive 4, we would go from the origin towards 270 for a total of 4 circles. So we would go like there'd be 1, 2, 3, 4, and we'd end up right in here. But that's not the case because we have a negative 4. So I'm going to go along the same line, but I'm going to go on the other side of the line when my radius is negative, and my point's going to exist right here. So I should still be on that same line, just on the other side of it, not going towards 270, but going away from it for 4 radii. Same thing with negative 90. I'm going to end up on that same line right here. And since my radius is negative, I'm not going to go towards negative 90. I'm going to go away from it, having point D be right here. Point E is going to be at 210 degrees. Let's find out where that is. And then my radius is positive, so I'm going to go 3 radii towards 210 degrees and get a point E here. And then 210 degrees is along that same line, and I want to go out nothing. So that's just going to give me a point on the origin like this. All right, let's see if we can plot some other points, because we can represent these using positive and negative angles along with positive and negative radii. So I'm going to start with just giving this one, looking at point B. I can rotate all the way up to 60 degrees, talking about right here. And to get to the other side, I would need to make my radius negative. So I would go over -2, and I would get this point. So I can do one like that. I could also go 240 degrees. That would be rotating from here all the way over here, and then just going and having a positive radius going up to. This one will be going -300 degrees. So that would be coming from here, going all the way over here along that line. And so I'm looking like right in here and then making my radius negative. So I go away from that. Looking at point D, we can go over to, we can say, well, we went up to 90 degrees. counterclockwise, and we went a radius of +1, so towards 90 degrees. Negative 270 degrees is going clockwise all the way around here like this. So looking at this line and then going towards from the origin to that 1 unit or 1 radii. And then this one will be going positive 270 degrees. So going all the way to here, looking at this, and instead of going towards 270 degrees, we're going in the negative, or our radius is negative, so it's going to go away from that. So that's how we can plot polar coordinates. We're going to also look at how we can convert between one and the other. And we need to consider the fact that based off of what we just did and what we know about plotting points in terms of x, y, we need to make sure that our rectangular coordinates are in the same quadrant as our polar coordinates. So starting here, I know that if I go 30 degrees is in quadrant 1, and I'm going in the positive direction. So I should be in quadrant 1. And so when I'm done doing my rectangular coordinates, quadrant 1, x and y are both positive. So I need to kind of keep that in mind as I go forth. So this is our conversion. If I give you the polar coordinates, converting that, we would find x by doing the radius cosine of theta and y as radius sine of theta. Remember, cosine is x, sine is y. And I did lie to you guys about using the unit circle again because we're going to use it here again. So it's just a matter of taking each one of these and setting it up like so. So I'm going to find my x value. I'm going to take this polar coordinate and find my x value by plugging in my radius and my theta. And remember, cosine of 30, that is our first line on the unit circle. That would be 1, 2, 3, square roots of 3 over 2. It's positive in quadrant 1. So I have 4 times square roots of 3 over 2, which would simplify to 2 square roots of 3. That's a good sign. X is positive here, just like, well, I need y to be positive because I need to be in quadrant 1. But then we're going to do the same thing to find y. And y, the sine of 30 degrees is 1/2. So I'm left with 4 times 1/2, which is 2. So these are my rectangular coordinates. 2 square roots of 3, which is more than 2, right? That's a positive number, so I go over 2 square roots of 3 and then up 2. I'm in quadrant 1, just like my polar coordinates says I should be. Let's try this one. So plugging in for x, we're going to do -3 cosine of theta. We have a 45-degree reference angle, and we are in quadrant 4. So quadrant 4, remember, cosine is positive and sine is negative. So that is my 45-degree reference angle. So that's going to be positive root 2 over 2. If I simplify this, -3 times all of that is just that. So that's my x value. Let's do the same thing for the y. Sine is negative in quadrant 4. And we're actually not in quadrant 4, by the way. 315 degrees is in quadrant 4. This polar coordinate is actually in quadrant 2, because if I go over to 315 degrees in quadrant 4, I'm not going towards 350 degrees. I'm going the opposite side of that, which would end up in quadrant 2. So this polar coordinate is in quadrant 2, so my rectangular coordinates also should be in quadrant 2. So when we're done with this, if I do negative times a negative, that's a positive. So my rectangular coordinates are this, and I need to confirm, are those in quadrant 2? Well, if I go to the left 2 and up, if I go to the left because I'm negative for my x and up because I'm positive, that puts me in quadrant 2, just like my polar coordinates are. So that needs to be true. All right, let's go the other way. This is our conversion factor. I give you rectangular coordinates, find the polar coordinates. To find our radius, we do x squared plus y squared. To find our theta, we do y over x for tangent, inverse of tangent of y over x. That should look familiar from the unit circle at least. So I'm going to go ahead and take these x and y values and plug those in to find my radius. I can type this all into my calculator and I get 18, so that's going to be r. And then I'm going to plug this all in, and this is going to say, okay, where on the unit circle, or what angle measurement is the tangent equal to square root of 3? And let's first consider what quadrant we're in based off of our rectangular coordinates. Both are positive, and here tangent can be square roots of 3, positive square roots of 3 in quadrant 1 and 3. But we want to ignore quadrant 3. Our rectangular coordinates are in quadrant 1, so we're only care about where quadrant 1 is. Remember, tangent's y over x, so where if I do y divided by x do I get square roots of 3 by itself? that would be at 60 degrees. So my polar coordinates converted from this rectangular coordinates would be 18, 60 degrees. Both should be in quadrant 1. If I rotate 60 degrees up from the polar axis and I go towards that 18 radii, that's going to still be in quadrant 1. All right, let's try this one. This one is in quadrant what? We go to the left and up, we're in quadrant 2. Okay, so let's plug this stuff in. We get square roots of 18 for r. Now we're going to do y over x. So 3 over -3, which is -1. Where's tangent negative? Tangent is negative in quadrant 2 and 4. Our rectangular coordinates are in quadrant 2, so I only care about quadrant 2's answer. And that is just going to be, that's 45 degrees away from the x-axis, so 135 degrees. And so our final answer would be square root of 18, 135. And so now y'all's task is to complete everything on 13.5. Complete all of that, and then the following Delta Math problems are going to go along with this stuff. Good luck. Make sure you ask questions as you have them.